There are a lot of symbols in the map. RT is all about direction finding, position reporting, right? So there are lot of symbols are here. You can see circular shape symbol, pentagon shape, triangle shape. Each and every symbol is having some meaning, and it
Okay, sir.
will help you in direction finding, position reporting, right? So we'll go through those symbol one by one. Starting from this
Sure.
pentagon symbol, right? So this symbol is indicating a VOR station. It is indicating a VOR
We
station.
are
And as we know that in this world, everything is having a name. Without name, there is nothing without name, right? Everything is having a
yes.
name. So this VOR will be represented by three capital letter. Three, always three capital letter. Example, Bravo, 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 Delta Papa November, Mike, Mike Victor, India, India, Delta. So this pentagon symbol is indicating a VOR station. So let's have a look on the map itself. And can you please identify some VOR station? See,
We are station Gold Victor Alpha, Golia.
Golf Whiskey Alpha. Right, Gwalior is
Yes, sir.
the name of the place. Golf Whiskey Alpha is indicating the name of the VOR station.
Yes, sir.
Papa Papa Tango, Lima Kilo November,
Kilo Juliet.
Kilo Kilo Juliet. Very nice. Kilo Kilo Juliet is located somewhere
Alpha Alpha Gold.
here.
Lily
Alpha.
Papa November.
Very
India
nice.
Mike.
Very nice. Super. So now my question is, see, what is VOR? Any idea about it? What is VOR?
Very high frequency omitting range.
Absolutely correct. It's a full form, right?
Yes.
Very high frequency. Now we'll start. What is VOR? What is VOR? Acha, see, do you know about GPS, Global Positioning System?
Positional system. Yes,
Uh,
sir.
so GPS is is a system which is giving us position, like navigational guidance. So the GPS is called satellite based navigation augmentation system, है ना? As
Okay.
bands. GPS is a satellite based navigation augmentation system. Why it is called satellite based? Because the antennas, transmitters are receivers are at space, right? That's why it is
Yes.
called satellite based. Same way, Sri, this VOR is a ground based radio navigation system. See,
Okay.
ground based, and it's a short range. It's a
Okay.
short range radio
Short
navigation
range.
system. Yes, short range radio navigation system. And the full form stands very high frequency omnidirectional range. Why it is called VOR? Because it it works in a very high frequency. The frequency range is, this is the frequency range here.
Megahertz.
Correct. 108 to 117.95 megahertz. This is a WPC question, very frequently asked. Hmm? Right. See. So now VOR is a ground-based radio navigation system. It's a short-range navigation system and stands for very high frequency omnidirectional range.
Why, sir? There is two one zero one zero eight two one
Uh,
one seven 1122 117.
Absolutely. So these are odd phase. See, VOR and ILS, they are sharing common channel actually. So as you can see, ILS localizer is having same channel but odd. VOR is given with even. So that is the another WPC question for you. Now proceeding to next thing. See, any system in this world, it will have three things: objective, principle, component. Any system in this world, it is made of three things: objective, principle, and component. And absolutely correct. So let me prove it. Any system in this world will be made of objective, principle, of and component. For example, see, washing machine. Have you ever used this washing machine?
Yes, sir.
So washing machine, we can say it's a system, right?
Yes, sir.
So what is the objective of a washing machine? To wash the cloth,
So, and dry the clothes.
dry
Yes.
the cloth, right? What principle it works? Washing principle is cyclic principle, right? It will rotate clockwise, another time it will rotate anti-clockwise. That is called cyclic principle. And in which principle it dries the cloth, Sri? Centrifugal force.
Ah, yes.
Like you will have a drum In the drum, you will have small holes, very small holes. You put the cloth, the drum will rotate clockwise at very fast rate, at a very high speed. So what will happen? It will create a centrifugal force inside the drum. Everything inside the drum will try to get out of the drum. Because of the drum is holding the content, the cloth will stay inside, and from the holes the water will come out. Right? What are the component of a washing machine? Motor, belt, control panel, body, lot of components are there. Let's say, see, you have removed the motor. So now, will it be used as a washing machine?
No, sir.
No. So now we can conclude it. Any system in this world, it will have three things in it. That is objective, principal, and component. Same way, the VOR is having three things. VOR is made of three things: objective, principal, and component. So what is the objective of a VOR? Let us have a look on this arrow, Sri.
Okay, sir.
Once again, Sri, once again. It is rotating clockwise, correct? Keep
Yes,
this
sir.
in mind, clockwise. So the objective of a VOR is to provide magnetic bearing. What a VOR provides? Magnetic bearing. Now, what is magnetic bearing? See, bearing means angular position. Angular position. Magnetic bearing means when it comes to magnet, it's the magnetic north it is showing. So to know the angular position of an aircraft, we need two reference. Any angular position, two lines should be there. Like until unless two lines are intersecting, you can't get an angular position. Correct?
Yes, sir.
Same way, this VOR is providing you magnetic bearing. So what is magnetic bearing? We'll understand here. So let's consider this is a VOR station, Delta Papa November. And in general, we know that it's a general rule. Any map in this world, the top portion is north. Correct? See?
Yes, sir.
Aware of it? So this map, the information we have is that this is a VOR and the top portion is north. Now,
Yes, sir.
there is an aircraft Delta here. How I will calculate the angular position of this aircraft or magnetic bearing? What is the magnetic bearing of this aircraft Delta? So magnetic bearing means angular position of an aircraft with respect to station from the magnetic north. So now north is top portion. So we got a line here.
Yes, sir.
Now aircraft position is this. Now tell me, north means it is 0, 0.
Yes, sir.
So what is the angular position of this aircraft Delta?
9,
9, 0,
0.
0, 9 or 0, correct? Magnetic bearing of aircraft Delta is 0, 9 or 0. Same way, what is the magnetic bearing of this Charlie?
1880.
180, absolutely correct. Magnetic bearing of Papa aircraft?
270.
270. What is the magnetic bearing of this Zulu aircraft?
045.
045. This thing you have told me, the answers you have told me by seeing the aircraft from the top, correct? It's a top view. What if I will tell you, you are sitting inside the aircraft, how you are going to tell the magnetic bearing of the aircraft? With the help of VOR, correct? With the help of?
VOR.
So objective is clear. VOR provides magnetic bearing.
Yeah.
Now, principle, it works in lighthouse principle. Lighthouse. You know, earlier days, nowadays also, there are a lot of lighthouses in India in coastal side. So the lights will be rotating clockwise. And those sailors, like the fishermen or some sailors are there, they used to drive ship on sea. They will have a compass, magnetic compass. Using the lighthouse light rotation, calculating the lighthouse light rotation and using the magnetic compass, they define their position in the sea, right? See? So that is the principle used here to find out the magnetic bearing. Now, components. It's time for the components. Two things you are clear. Objective is it provides magnetic bearing, and principle, it works in lighthouse principle. And the component, we have two components are here mainly. So one is on the ground, we call it transmitter, VOR transmitter. Inside aircraft, we have VOR receiver. From the top view, the transmitter looks this way. In the transmitter side, we have two different type of antennas installed. On the center part, you can see this is called reference antenna. It is a omnidirectional antenna, Sri. What type of antenna it is, Sri? Omnidirectional antenna. So, around this reference antenna, we have total 51 variable antennas. And these are directional antenna. What is the meaning of omnidirectional antenna and directional antenna. Let me make you understand. On the center part we have a reference antenna. Omnidirectional means it will transmit its signal everywhere in all the direction, 360 degree. Here it is like this. Understood? See. Now you will see how the signal is transmitted. Omnidirectional. Understood? See.
Yes.
So this is now after this omnidirectional signal is being transmitted everywhere, starting from the north. This variable signal antennas, the variable antenna will start transmitting one by one, right? These are directional signal. Starting from north, it will keep on transmitting clockwise. So now we'll be back again to here, right? See, so as you see, as you have seen here, on the ground part you have transmitter, on the air part we have receiver, right? See, okay. So to understand the whole theory, I'll kindly tell me, every signal will have a polar diagram, see, like this.
Yes, sir.
This is one diagram and this is another diagram. Can you tell me what is the difference between two diagrams? See, this is there is a phase difference. There is a,
Yes, sir.
what is the phase difference between these two signals? See,
It's 90 degree.
absolutely correct. It's a 90 degree. Phase difference is 90 degree. Now coming back to the, so the reference antenna will transmit signal omnidirectional signal. That means 360 degree at a time.
Yes.
And the variable signal antenna will transmit signal one by one. Right? See. Okay.
Yes.
So this thing works very fast. We need to slow down the time to understand how exactly it works. Like transmitter on the ground, we have a receiver inside a aircraft. To provide signal to the receiver, we need an antenna. The VOR antenna is located inside our aircraft, right? See here, vertical stabilizer.
Okay.
So this signal will travel all the way from the belly of the aircraft till here. Here we'll have a receiver, or you can say computer. This is your VOR computer installed here. All the calculations are done here. Now we'll understand what are the calculations done here.
So
And the computer
here,
will be here.
okay.
Avionics bay, it is called avionics bay or AT view. Some aircraft it is called E&E compartment. Okay, all the calculations are done here, or you can say signal processing are done here, right, in this computer. So now we'll understand how the system actually works, how the signals are transmitted. So beginning from the, so we'll start this process is so fast. See, we need to slow down the time to understand the process. So initially the reference signal will transmit all the direction. Transmitted, all the aircraft will receive. All the aircraft has received the reference signal. Let's consider this is the signal. All the aircraft has received. Right? See. Now, once the reference signal is transmitted, one by one, the variable signal will start transmitting one by one. According to the position of the aircraft, respective aircraft will capture respective signal. Now this aircraft, let's consider aircraft A. This has received a variable signal. Let's say this type of variable signal it has received. Now another aircraft. No aircraft will receive other aircraft signals, right?
Yes.
Now this aircraft has received, let's consider this signal, correct?
Yes.
Now let's consider this is keep on rotating. This happens in fraction of second, right? See, this happens in fraction of second. We have slowed down the time. Now this aircraft has received this signal. So here, the same way the whole signal will keep on rotating, right? See,
Yes.
again starting from again the omnidirectional will transmit. So this aircraft A has received two different signals, one from the reference antenna, another from the variable antenna, right? See, the receiver of the aircraft A will process or will calculate the phase difference between both the signal, and the phase difference is obviously 90 degree, right? Same way aircraft B receiver has calculated the phase difference. Obviously it is 180 degree. Here 270 degree. So what will happen? All the signal will be received by the antenna here, and this signal will be transmitted to the computer here. These are the computers located here, inside the aircraft. So this computer will calculate what it will calculate. It will calculate the phase difference
Yes.
है ना, between a reference signal and
Directional.
variable signal, variable signal.
Very
Yes, and it will generate a voltage which will go to indicator in the cockpit. In the cockpit, we'll have RMI, radio magnetic indicator.
yes.
Right, see? According to the voltage generated in the RMI, the needle here will point towards the VOR station, and at the opposite end, you can see the magnetic bearing. Right, see? Okay, now see. Let's consider there is no indicator. Now, from the top view, you tell me what is the magnetic bearing of this aircraft with respect to this VOR. Bravo, bravo, bravo. Tell me, see.
250.
You said almost 250. This is from the top view. What if you are sitting inside the aircraft? You will have, if you are sitting inside the aircraft, you will have this indicator, correct? RMI. What I told you, this pointer will point towards the station, and the opposite end you will have.
We are in front the station.
What is the magnetic bearing indication here?
255.
So because we are human, we can take hypothetical. Eh? You said 250, but bearing, the indicator will tell you the exact value, correct, Sri? Now you understood how you are seeing magnetic bearing inside the aircraft. Is it clear? Magnetic bearing.
Yes, sir. Magnetic bearing is clear.
So now we'll conclude the whole system again.
And one more thing is there. Now what is it again?
That is the ADF. That is a different part. Sri.
Okay.
We'll discuss later on. Don't worry. Okay. So now, Sri, we can conclude the whole system now. So VOR stands for very high frequency omnidirectional range. It's a ground-based radio navigation system. It's a short-range radio navigation system, right? In system, will have three things: objective, principal, and component. Objective of a VOR is to provide magnetic bearing. Principle is lighthouse principle.
Lighthouse.
Components are two major components are there. One is ground. In ground, correct. On ground we have transmitter. In aircraft we'll have a receiver, right?
In transmitter we have omnidirectional and
Omnidirectional antenna on the center part, and variable antenna, 51 variable antenna right round to the reference antenna, right? The omnidirectional antenna will transmit signal on 360 degree. Starting from the north, the variable signal clockwise it will transmit. A respective position of the aircraft will receive a respective signal, and the signal will be processed in the VOR computer inside aircraft, and it will transmit again processed signal to the radio magnetic indicator in the cockpit. The indicator pointer will be indicating the direction of the VOR, and opposite end will get
from the
bearing. Absolutely correct. Super. So how many sorties you have done today?
how many sorty? One sorty.
Only one sortie? Daily one sortie?
They were planned for two, but they can turn into only one.
Okay, no problem. So Sri, now what I said, VOR provides magnetic bearing, right? So as I told you, VOR is a ground-based radio navigation. So will it help us to plot position in air?
No.
Yes, it will help us, but it
Yes, it will help us.
cannot tell the exact position, right? So VOR is unable to provide position. It is not capable of providing position because it can only give magnetic bearing. Right here, aircraft Bravo, Charlie, Delta, they all, if I'm saying I am in an aircraft which is at radial 090 with respect to Tango, Romeo, Victor, VOR. So you cannot define in which aircraft I am flying, right? See?
Yes, sir.
For that we need, see, in air we plot three-dimensional position. What are the dimensions, see?
Altitude,
Absolutely correct. Altitude, radial,
radial,
or you can say magnetic bearing, same thing, and distance.
distance.
Absolutely correct. Three-dimensional position. So now we know about the radial or magnetic bearing. Now distance. From where we'll get distance? DME, distance measuring equipment. So this DME provides us slant range distance. So we'll go through a brief. Like DME is having aircraft, inside the aircraft we'll have DME interrogator. And the DME will be always co-located with a VOR station. Correct? It will always co-located. The moment you tune a VOR frequency, DME will auto capture. Right?
Okay, sir.
So inside aircraft, you will have a DME which will interrogate the ground DME transponder. Right? and the transponder will give you a reply about your distance from the station, like in the form of nautical mile. So DME antenna is located here somewhere small, and the computer will be, as we know that the DME is located with co-located with VOR. The same way DME will be always near to the VOR in aircraft also, and
Yes.
here will be the indicator.
So
So
what is this DME L and R, left and right?
in aircraft two systems are there, na? Like DME1, DME2, same way left DME, right DME.
Okay.
The moment you tune the viewer station, the DME all auto capture. Now let's see three-dimensional position. So now see, if I'm saying my position is radial 00020 DME, Tango Romeo Victor. So which aircraft I'm flying?
Alpha.
Alpha, absolutely correct. And same way Charlie is at DME.
09.
In examination, you have to write down this way: DME
Okay.
20 radial 090 Tango Romeo Victor. Right? Charlie, tell me about this Foxtrot aircraft.
Foxtrot, sir. DME 20, radial 270, Tango Romeo Victor.
Okay. Reference you have to give from which VOR station you are taking reference. Right.
Okay.
See, you have seen that with two dimension itself we are getting the positions
Yes.
from the DME and VOR itself. Why it is required three dimension?
So
We
we can calculate the difference, how
now
far,
now Sri,
which altitude.
no Sri, come here. For example, here, let's take there is a blue aircraft. Huh?
Yes, sir.
This blue aircraft, let's consider it is flying at 18,000 feet, and this aircraft Bravo is flying at, let's say, 11,000 feet.
Yes.
Now, if I am saying Sri, my position is radial 09010 DME Tango Romeo Victor. So, in which aircraft I am flying? Can you tell me, sir?
No.
No? If I say flight level 180, then
Then it's indicate Charlie.
no. Flight level 180. This blue one, not Charlie.
But you mark for two, sir.
Come,
आप mark करके 1800 बोला था, 18,000. Then you said Bravo is on 11,000.
Bravo is on 11,000. There is a blue aircraft again made. See here.
अच्छा अच्छा, okay okay, I understood, sir.
Charlie is 20 DME. No,
Okay okay, understood.
it
One
is
one
10 DME.
X-ray is the blue one.
Okay. Clear. See what is the third dimension is indicating.
The
See,
dimension is indicating the
L,
altitude.
yes. So all the three dimensions are important to plot position in air, right? See.
Yes, sir.
So now, see, next point is there is one more dimension you may be knowing about it: time,
Okay.
right? So whenever you are plotting position, along with the position, you have to tell the time exactly what time you are plotting the position. The time is also a dimension to give a precision position information. Is it clear, Sri? Now, what is the use of this this thing in the map? This thing in the RT. So as we in the beginning we have discussed, RT is all about direction finding, position reporting, right?
Yes.
So see, you can see this is the map, and there will be aircraft appear here. Here is the aircraft.
Okay.
Can you tell me the position of this aircraft?
Okay, yes, sir. Radial 250,
25
25 DME.
25 DME? No, it's not
Lima
radial.
Kilo November.
It is radial 270. See,
अच्छा, okay. 270.
DME 25 Lima
25
Kilo November.
Lima Kilo November.
Now proceeding to next aircraft. Can you see this aircraft here? Sri?
Yes, sir.
Okay, tell me, Sri.
Coming on opposite of radial 266,
Okay,
DME 200.
200? No, not 200. Let's say it is about 80 or 70, 80, 90 DME. 90 DME.
Okay. Sir, I have one doubt, sir, because it's very close to Bravo Bravo number, very far from Papa Papa Tango.
Okay.
So from nearest one we will calculate, na, sir?
It is all depends which station frequency you have tuned.
Okay, understood.
If you have
Okay.
tuned Papa
Now
Papa
we are
Tango,
tuning with Papa Papa Tango, then flight level, then hypothetically we can give something.
yes. Okay. Next here, this aircraft.
Radial 175 DME 50
50 only. Okay,
50
see.
altitude.
So,
Pardon, sir?
so you are clear about all this VOR, right? See.
Yes, sir.
Okay. So same way, some more symbols will be there, like circular symbol. The circular symbol indicates NDB station. What is NDB? NDB stands for
Non-dead
non-directional beacon, right?
beacon.
And the name of the NDB will be indicated either